Hello. We're going to go ahead and begin our Chapter 1 discussion. What we're going to talk about today are the parts of a program. We're going to get a Java program going using NetBeans, and which you would have, we've got some videos in there that you would have seen on how to actually install NetBeans, and of course there's lots of stuff out there. Then we're going to talk about the program parts. What are the different parts of the program? Then we're going to talk about when you're actually writing the program, some of the parts that you're going to be responsible for, such as input, process, and output. And then we're going to talk about the Java virtual machine and interpreted languages versus other types of languages. Then, of course, we're going to get into the main part of Java, which is everything is an object. So we got to start the discussion about objects right off the bat. And then we'll have a light discussion on inheritance. But the main key part of today is, hey, how do I start writing code and turn in my assignments? So we're going to begin that with your first main assignment, which would be just to get a program working. And we're going to use NetBeans. I've got NetBeans installed, so I'm going to just type in NetBeans and bring that up. I've got version 16, it looks like. Whatever version you guys have, it'll be likely pretty close to the same. I've actually already created a hello world here, but let's go ahead and go through the steps together. And I probably should have. Here's the thing: is you probably don't want to do. If you can, try not to do any of that. What I just did was deleted the project from NetBeans, but I didn't delete the source files of the project that I previously created. But yeah, let's not get into that. We're going to start with our project here. Let's go to File, and we're going to say New Project. Now we're going to go ahead and choose Java with Ant. And so you'll have the different project types. Now, since I teach other courses, I've got like HTML5 projects I can do here, PHP projects. I never use this for C++, but you can add other languages for NetBeans to be able to work with. It's really good for HTML and JavaScript and of course PHP. But we're working with Java for this course, and you can just choose Java with Ant and over here a Java application. Then you're going to hit Next. Now here's one thing that I really want to kind of give you an idea of how to do things. Don't hide your project folder somewhere deep in your directory structure. Just put it right on your desktop. So we're going to go ahead and go to Browse. I'm going to click on Desktop, and I'm going to say Open. I'm going to choose that. I'm going to say Open. And then what it's going to say is the project location is on the desktop. And the project folder is going to be given the name of our project. And what we're going to do is we're going to do Hello World. This is going to be our Hello World. Let's say CH1. And then we have this down here where it says create a main class. Main is actually a function that begins with most C-based languages. We call it main because every program has to have an entry point where it begins. It's mechanical top-down processing of your lines of code. So we're going to opt for them to go ahead and create the main class and function for us in the project, so that we have our starting point all ready to go. Then we're going to go ahead and click Finish here. Now it's going to create your project, and it's going to add some source packages to the project. So let's just kind of look at this real quick. This very first one, this is called a package. And what a package is it's what we call a namespace in other languages. Basically, it's kind of like a box that we wrap around code to make sure that the variable names that we use for our variables in our code don't clash with any other code that's written for code that we're using from other libraries, such as the window system output print function. So you're given this software development kit for Java, And in that software development kit, it comes with pre-built libraries to do simple things like input, getting stuff from the user, outputting to the standard console output. And if we were to have a variable that would clash with a variable of one of these libraries we're using, then all of a sudden the program wouldn't really work very well. So what they did is they said, okay, well, with everything you create, so that we're saying declaring this as a package, we're saying this is a box called Hello World Chapter 1. Over here, here's the box. And in that box is our Java class called Hello World CH1. And what that means is that we have it safely in our namespace or our package Hello World. Notice that this has capital H and a capital W. That's how it's different from this guy right here, because they can't be the same. The package is the wrapper that we wrap around our object that we're authoring to make sure that any variable that we create in here, say that we want an integer called out or something, p out or whatever. So what if that was a variable that was used in another language? And so that would be a big issue. We're getting error here because we're not using it. But anyways, that's the idea of a package. We're putting our object that has our main in it inside of that wrapper. And you can see it's inside of it as it's indented over here in the projects window of your software or of NetBeans. So it's tabbed in because we put it inside of that wrapper or that box. And therefore all our variables are safe. And we can just say in another line of code or another object that we want to use the package Hello World CH1, and then it opens up that wrapper so that we have access to the variables and the classes that we have inside that package. So everything has to be inside of its own package or its own wrapper to safely have our variables so they do not clash with some of the libraries that have been developed and we will be using for our own code. So once we declare that our wrapper is called Hello World CH1, all lowercase, then inside of that wrapper we can declare an object. Now you can only declare one object for every source code file, for every .java file. Your .java file is a text file that is that declares or is where you write your code essentially. If we wanted another object, we would have to have a whole nother .java file to go along with it. And then we could also put it under a different package so it didn't clash with our package right here. We could also have other Java files underneath this same package so that they're all in the same namespace and they're all those objects are kind of together in the own what we would call the Hello World CH1 library. So that's kind of the idea behind packages. If you've learned about namespacing and the reason for it, you can research namespaces for other languages, or you can just research more about Java packages and it'll describe the same type of behavior and the need for it. So once we have our object, every starting code file needs to start with a declaration of an object. But every program that we have has some kind of entry point where we actually start writing code that does stuff. You know, it has behaviors. And so basically the behavior being that it executes line by line from top down. And always within an object, we will have our runtime code. That's a function that does something. And so the object is going to contain it. And we can think about the object as a box that can contain variables. We can put variables for the box up here and whatnot. And then it will be accessible for all functions declared inside of this object. But since main, there can only be one main. There can only be one entry point in an object. So, or in a program, excuse me. So that is done with that special keyword main, and this is the only place that you can use it. Now this static part means that basically it's saying there is only one main, and that's what the static is doing, because we can actually have other functions that have different names, but we would not have them static because we can have multiple instances of that function on the stack or that function call in the stack, but we can only have one main function declared. And that's why we make it static, because there can be only one entry point to a program, therefore only one main in any place. So if you have a program where you have more than one main, it's going to fail because it's not going to know where it starts. But you're going to be learning more about how to add other objects and objects that contain functions and then call them from your main. So essentially your main is your starting point, and then everything else will be libraries that you create. You're not going to start off right off the bat creating your own libraries and your own packages. We're going to be working with inside of a main mostly to begin with, until you learn about functions, and then we'll go into more about objects and functions. But we're going to be learning about objects as we kind of go along. And so everything needs to be inside of an object with a full object-oriented programming language like Java. So this is where our program actually starts. Now what we're going to want to do is we just want to output something, and what we're going to do is we're going to use the Windows, I think it's window dot out print. It's like system, windows.system, if I remember right, system. And you know, guys, I'm always looking stuff up and having to pause because I always use different languages. And this is something where I would just Google right now, how do you do an output in Java? And so it's going to be windows.system something. And this isn't a bad thing. You can do this on your exams and whatever. You can just come up and say, hey, I am working in Java. I've forgotten how to do that output. Let's just go ahead and type in Java window output example. And let's just get an example of how to do it. How to output text in Java. Stack Overflow is good. We got some simple examples. And it looks like this is not going to be very helpful. Let's not go here. But let's just do, how about this? Java console output. Console output. Oh, console log. Let's just do console output. And maybe we'll find some examples. Your book also has it, of course. Oh, it's system.out. Okay, yeah, now I remember. Okay, now let's go back into our Java, our NetBeans, and we can continue on because now we've got an example. So it's window.out. And am I doing it wrong? Let's see. What do we got? System.out. Oh yeah, I'm way off. System.out. Okay, let's go. System.out. There we go. Out. And we're going to do dot. Now, you see here that we've got these pop-ups. This is called IntelliSense. So we can kind of look at everything that we have available in the system library. And see, we're opening up the box, the system object box that contains a function called out. And in that, or an object called out. And in that object called out, we have a print function that we can use. So what we're going to do is we're going to choose a print function that we were going to use that would work. You know what? We can do a print line. We can just do a simple print. I believe the print line probably does a \n, which is a new line character at the end, so that your output goes to the next line. If you just do a simple print, it won't output to a \n or a new line character. So what we're going to do is we're going to just do print here. And then what we're going to do is we're going to just use a literal string here. We're just going to output a literal string. And when I'm using a literal string, you notice I'm putting it in double quotes. Hello world. Okay, now let's just play around with this a little bit. And let's execute this. And what we can do up here is we can go up here and hit play. And it's going to run, and you're going to see down here, this is actually your output. You see where it says hello world? Okay, that's your output. This is what I want you to take a screenshot of. It's very important that you do submit your homework correctly for me. Okay, so what you're going to do is you're going to open up Word and you're going to create a blank. You can do this as a PDF or you can do it in another Office program and output it as a PDF if you wish. DocX is really good. I believe you can get Office through the school. There's a link in your on the web that you can do. But then you're going to take and you're going to grab the text of your code. I don't want a screenshot of your code. I want the text of your code. You're going to grab the text of your code. You're going to copy that. You're going to go to the Word. Don't forget to label this your name and then chapter one, first program or assignment. Here's where you would put the assignment number. You would put maybe like number 4 if you're solving number 4 in the back of your programming or the back of each chapter of your book. That's what I would want your label to be. Here we're just going to do a first program. And then we're going to paste our code. Now don't worry too much if it does any kind of try to use a source if you're doing a special paste. That way it doesn't modify the characters with some simple auto correct and all that kind of garbage. So this is our code that we're going to submit. Now here's where the import bit are. I want you to prove that it works. You have to show me a screenshot of your output. This is your output. This is what I want a screenshot of. So what you can do is you can hit print screen and then just grab the box, choose the box, and when you choose that box, when you hit print screen or use the Snippy is a good one to use too, Snappy or snipping tool you can use. But then once you get the selection and it's copied on your clipboard, just go into Word and hit Control V or right click and say paste. And see, here's the screenshot of our output. That's proving to me that you got this running. And then of course you've got the code. And you're going to do this for every programming assignment that you have. And I want you to test, you need to test the input and the processing and the output of your code. That is the goal. Sometimes you will need more than one screenshot to show me that everything works. And so the more verbose you are with your screenshots, you don't have to go nuts with them. If you've got just a simple output, just the simple output showing that your output works correctly from your process, which I can look at your process. I can look at your code for your process. Here we're not doing any processing. We're just doing straight up output. This is what I want for your assignment. Now you may have other assignments that you will go down here. You will do another label, chapter 1, number 5. And then you'll put the code and then you'll copy and paste the output below it as I've got here. And then this is what you're going to submit. So remember, you're not going to do a screenshot of your code. You must do that as text. You must do a screenshot of your output to prove that it works. All right, I'm going to take a small break here, and then when we come back, I'm going to talk about the Java virtual machine. I'm going to do some scribbles. We're going to talk about objects a little bit and inheritance and kind of a little bit on how inheritance works. But the main thing that we really need to discuss is what you're going to be doing with these programs. And then we'll play around a little bit with that print statement and the new line character. Actually, let's just do that real quick. We're going to do a \n here. And what that'll do is that'll make a new line. And you see how it's got this build successful here? It's kind of right next to hello world. What it'll do is then add a new line so that part goes. You see now it's now down one line when before it was all together. And if you can hit this, and if you do this again, and you take out the \new line, all those hello worlds are going to be together. Okay, or you can just do this. You can say print line, and that function will put the \n at the end for you, so then you can have your line separated again. And you see how that works now. Okay, so you can inject the new line character in, or you can use the print line function. All right, guys, we're going to take a break and we're going to go over those few things as we progress. It'll be quicker for you, guaranteed. Okay, we are back. Let's talk about what Java is real quick, and kind of the issue and the reason why we had Java and other interpreted languages. It's an interpreted language. It's a little bit more, I guess, you know, when you can compare it to other interpreted languages, it's kind of the same thing, but it's more tightly coupled than like JavaScript and, you know, some of the other interpreted languages. But it's, you know, Java was built to solve basically a problem, and that is, like, let's take for instance like C++. C++ is you know, another language, but the problem with C++ is you write the code and then the compiler puts it directly to your machine code, the zeros and ones. And so what that causes a problem with is the machine code for the code that you wrote in C++, you would have to have a different machine code or a different code for a Mac, the different code written for Linux, different code written for Windows. And so essentially, if you wanted to write a code that was cross-platform, you needed to write it in 3 different times, 3 different ways. And that was a huge issue because we wanted cross-platform capability. C++ is still needed because you know, it's faster and more efficient. And then, you know, for things that we need just for that, we will use the machine code of C++. But we don't, you know, that amount of development, having to redo it each time for each platform, or write code that could intelligently switch itself using include statements to compile to a Mac, Linux, or Windows, which is extremely complicated and buggy in itself, it still is a problem. We haven't really, it's not solved. We'd have to actually write it 3 different times. But if we wanted to develop something that was truly cross-platform capable, this is my little scribble for what we call an interpreter. An interpreted language is a little bit different. What you do is you write code just once, and then you have a different interpreter. In this case, we call it Java Virtual Machine Code, JVM. I also call this an intermediate language. So essentially, we have a whole nother process that takes the code that you write and interprets it to Mac. And then we have a whole nother Java Virtual Machine that takes the code that you write and interprets it to Linux. And then we have the same thing. So you're only having to write your code once, and then the Java organization, they will write the virtual machines to interpret it to each separate system. And that works really well for things like JavaScript, also PHP. PHP is loosely interpreted. But that's kind of the solution here, so that we only have to write one bit of code, and then the Java virtual machine will do the job of taking the code we write and converting it to the right machine code for the system that we're on. So every system that you're on, if you are on a Linux system, you would have to download and install the Java virtual machine for the Linux system. And then it will be able to take your regular Java code and convert it to the machine code for the Linux processing, and you know, vice versa for Windows and Mac. But here's the thing here's the problem that it also causes is there's a lot of overhead for Java. C# is the same way. It works with an intermediate language, and even JavaScript and other interpreted languages have the same problem, is they are not as fast. We have this whole other layer, and that way, so there are certain things that we cannot do with Java because it's not fast enough. And I mean, no matter what, speed is still a computer's intelligence. So it's not the solution for everything, but most things it solves for. So it's really an excellent way of being able to write your code once and having it fully cross-platform capability for it. So that's kind of why we have Java and other intermediate or interpreted languages. Even though it adds a little bit more overhead and is not as efficient, that capability outweighs that inefficiency. Now let's go back to our programming. And one thing that you're going to be doing is you're going to be getting to a program and you're going to be like, oh geez, where do I even start? And here's where I want you to kind of think in your process of developing your code, is that your code always starts with some kind of input. Sometimes your code does not have an input. Sometimes it just has an output. In this case, our code just has an output. So you're going to have some kind of input, and I'm trying to get my fingers on the keyboard correctly here. But you can just lay out your code steps as your input. What are you going to get from the user? Then you can lay out your processing. What am I going to do with that input? Because no matter what, when we're working with computers, everything's just a number. No matter what, we got different types of numbers, but I mean, the screen that you're looking at is a sequence of numbers. How? Oh, well, there's a location of a pixel, and every pixel of that location has a red, green, blue value for what kind of color it is shown. So everything comes down to a simple number in computers, no matter what. So whatever you're creating, no matter what you're dealing with, it's always a number. Even these characters are numbers. And we call it the ASCII code chart. Let's bring that up. The ASCII code chart. Even characters are given numbers. So the ASCII code chart is used as the lowest level of characters for any computer. I don't care what computer you're on. The ASCII code chart is your lowest level of input. You could have a computer that is using Chinese characters. At the very lowest level, it has the characters that are done for English. The Chinese characters come in after these 0 to 128 characters, or 120, 0 to 127, basically 128 characters, which is the amount of characters that are on your keyboard. So every item in your keyboard has its corresponding number. So like the letter A, the uppercase of letter A has the value 65. The lowercase of the letter A has the value 97. And you can convert those back and forth between numbers and characters. So regardless of what you're doing, it's always a number. And that's where it makes it so simple. But because it's so simple, it becomes difficult. Because it becomes difficult to do complex tasks with that simplicity, if that makes sense. Going back to here, you're going to always get some kind of number from the user, or if you're not getting a number from the user, you're going to be processing some kind of value. And then what are you going to be doing after you process or you get an input? You're going to have some kind of output. You're going to show some kind of value change. Either it will be some pictures on a screen, whatever. You're starting out with simple output, such as just console output to your console log that shows up here for you. And so whatever you're doing for programming, it's always going to come down to those 3 steps. It may not have one of those steps, but you're always going to have these 3 steps. So when you get to like that step where, oh, I don't know what to do, how do I start? This is how you start. Lay out your input. Lay out what you're processing. Lay out what your output. Write it in clear English first. Then you're going to know what kind of variables you need to declare to get your input. And then you're going to know that those variables that you're going to need to use to process, and those numbers that you're going to process. And then once you have those numbers that you've got for your input and that you've processed, then you're going to use those numbers and you're going to output them to the screen, processed. And then you'll be doing the screenshot showing me that you've completed the task. So let's go on. We've talked a little bit more about what Java is. Let's go and let's just talk about objects and inheritance real quick. And we're going to go to the whiteboard for this, and I'm going to, let's see. I totally forgot how to make a new board. Oh, here we go, new whiteboard. There we go. I guess maybe I'm not being too forgetful today. I don't want that. All right, there we go. Okay, so we first start out with our object that has main, and this is our hello world object. Hello world. And we can think of the object as a box. And inside of that box, we have our main function. And we can have variables, integers, numbers, just numbers, whatever. But we can have numbers inside of that object, or we can have numbers and variables inside of main. But the object itself, kind of think of it as a box. Now, we can also create some other boxes. So we can have another box here that we call is, let's say that it's an animal. And we can have variables that describe this animal that we can use for modeling, such as like height, weight, and so forth. So we can have all kinds of different variables that describe that animal as an animal. Now here's where object programming really kind of changed things. Before object-oriented programming, literally I would buy some new hardware that I was really excited about, and I would have to wait sometimes for maybe a full year before all the software was developed for that hardware. But when we went with object-oriented programming, that changed. What happened then is the software already is written before the hardware is created. Crazy, right? Well, here's what made it happen. Is let's say that I built this animal, and I built inside of animal all the variables I needed for animal, such as height, weight, whatever else I have as part of that animal. I could have eye color, whatever. And I built everything I need inside of animal for what I need for an animal. And let's say that I come along and I need to add to my code and I need a special kind of animal. So then what I can do is I can create another box, another object that I call, let's say, a tiger. And I don't need to create height, weight, eye color for tiger. All I have to do is inherit from the animal class, and now the tiger becomes an animal. And it has all the code that I wrote for it. The height, the width, the eye color of the animal, the functions that work upon the animal, everything needed for an animal, the tiger can take on and as an attribute. And it has everything about the animal that, for a tiger. But here's the thing about inheritance. You always go from a generic specification, a generic object, to something that's more specific. So then here I would put variables that differentiate a tiger from any other animal. So a tiger, what is a tiger specific? So I would put variables in here that is only for a tiger and only what a tiger has. And let's say that a tiger is the only thing that can roar. So I would have a roar function. I'm probably misspelling that. But the idea is, if a tiger is the only animal that can roar, I would put the roar function in tiger, and therefore, since tiger is an animal, it takes on all the code that an animal has, but then the more specific code that makes the tiger a tiger, like a roar. And then I can also, on top of this guy, I can inherit something called a super tiger, and a super tiger maybe has a function, things that make it so the tiger can fly. And so now we can take on all the attributes of tiger, which takes on all the attributes of animal, and then just write the part of the tiger that allows it to fly. And that's where object-oriented took over everything, because now we can develop the code for specific hardware, and we can actually write it before it even exists by just inheriting the attributes of code that we've already written, and then just adding the specific parts that we need for that particular inheritance hierarchy. We call this an inheritance hierarchy. A tiger can inherit from an animal, and it's specific. And then we have a super tiger. We want to always go, and we call this a base class. We always want to go as a base class, the generic. And then as we inherit from it, we go up in specificity. So that's the rule of inheritance. And that's the way that we're able to write code for code that doesn't exist yet. That's the key. You're writing code for something that doesn't exist yet. And to be able to inherit from it and make it more specific and have that code written before the hardware is even created. And that's what changed everything. And that's the idea of objects and inheritance and why it's so powerful. So we're going to be talking about some of these relationships as we progress. You will be learning about inheritance more. I wanted to give you some of the rules of inheritance. You don't ever want to go and have a base class called tiger down here, and then animal inherits from tiger. That doesn't work because we're going from specific to generic. So you always want to keep in mind on those rules of inheritance so that you can write code for the future. That's what it's for. Writing code for code that doesn't exist yet. And that's where things changed. And you guys know about the dot-com bubble. When we started doing object-oriented programming, just everything. We had software for everything already done, and we could implement it. We didn't have to rewrite things that would take hours or years to complete. We could write code for things that hadn't been created yet. All right, guys. There's some more in chapter 1. I think we pretty much covered the basics. I do want to point out to you about binary and how binary works. So we're going to go back to the whiteboard real quick. When we think about binary numbers and your variables that you have, everything is a number at a specific level. So just a little bit more knowledge on how those numbers work. It's all in binary. So essentially, when you think about a binary number, we put our placements above that binary number. Our placements are kind of like in a base 10 number system, but since we're only using base 2, our placement values double each time. So our first placement value is a 1, then it doubles to a 2, then a 4, and then an 8, then a 16, and a 32. And this continues on. This goes all the way up to 64, 128, 256, 512, 1024, 2048, blah, 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 blah. But let's say that we have a binary number that has a whole bunch of zeros in front of it, and we got 101. So we could just shorten this by saying our binary number is 101. Well, how do we convert that to decimal? Well, we put the binary number in its placement values, and wherever you have a 1, you count that number for the total. So we say, okay, we have a 1 in the 4's placement. That means that this number represents 4, at least 4. We don't have anything in the 2's placement. That's a 0. We know we got all zeros before, so we don't need to worry about that. But we have a 1 here in the 1's placement, so we say that that's a 1. So in decimal, this would be 4 plus 1. That would be 5. So the binary number 101 equals 5. Okay, so if you do here, if we change this to a 1, so we had the binary number 1101, we would put up here, we would have an 8, that we add into. So now it's 8 plus 4 plus 1. So we would add, so the number 1101 now is, 12 plus 5, is that 8? 12 plus 5, that number is 17. Okay, now we don't need to do this with pen and paper. It's just stupid. So here's where things are really cool if you want to really play around with it. Bring up your calculator. And
we're going to go to the programmer part of the calculator. And we're going to see it. We're going to choose here. I just selected programmer up here. And then over here, I'm going to use the special, I want it to use the toggle. So right here, let's just do 1, 0, 1. We got a whole bunch of zeros before. It goes all the way up to 64. 1, 0, 1 is 5. Let's add another 1 here. 1, 1, 0, 1 is 13. Did I count that wrong? 8 plus 4 plus... I probably messed that up totally. Oh, yes, I did. It's not 8 plus 4 plus... Oh, my God. You guys are probably thinking I'm nuts. That is totally wrong. It's 8 plus 4 plus 1, not 8 plus 4 plus 5. I totally messed that up. Hey, that's an excellent example of why we should be using the programming, the programmer. So if you want to, hey, what is the number 110000001101? It's 3085. So this is kind of a nice way of looking at it and kind of visualizing the things as binary. And one of the kind of the first things that I talk about. I'm not going to talk about much else because a lot of your reading in chapter 1 is kind of the dry stuff that a lot of people kind of really already know about. So we kind of hit the high points from the chapter. I'm going to continue from chapter to chapter. If you are working, I'm going to try to stay a week ahead of you guys. And if you get into a module without a video, it'll be there shortly, or if it's already done, of course you can work ahead and see it. So I am looking forward to our chapter 2 video coming up later. Thank you. Bye.